Hello, everyone. Good morning or afternoon or evening, whatever it seems to be for yourself as when you see this. We're going to get started. Now, you probably kind of got the gist of how this is all going to work. You got emails or letters in the mail, kind of telling how we're all going to, start up our classes again so that we don't get a huge slide in skills when you guys, eventually return, uh, hopefully in the fall. I don't know. We'll just wait for the orders, okay? We're gonna get started, and I did some videos on radians, and so now what we're gonna do is I hope only 3 people. No, I'm sorry. Your class turned in about 7 people turned in that. I would encourage you to go and review that and do that. I am going to put these assignments in the gradebook. They will be italicized so that we as a staff can keep track and see who's doing what, and it won't count towards the grade though. This is not going to be credit bearing because it's basically not an in-class lecture, and you guys can't get credit, in-class credit for something that's online like this. So we will, as a staff, though, keep track of who is doing what. So you will get feedback for this, and I will be giving quizzes, and you'll take quizzes. It will go in the grade book, but it actually won't count towards your 4th quarter grade. But we will have that data for you, and we'll kind of keep it in our systems and see what happens next. Okay. So what's important, I think, for you, especially as a pre-calc class, is that you guys keep honing your skills. It's been a month. So we got to keep them sharp and make sure you don't forget this stuff, and move forward in your education. So with that aside, I want to show you real quick. Basically, here is like the website. This is for Marcellus ORG profiles. This is my website here. There's not a lot of information. It's just the links. Okay, so you guys know where Google Classroom is, so that's no big deal. Here's the Imagine Math link. So usual 45 minutes for previous things that you guys forget about. I'm going to give you credit for that as well to put into the grade book. But here is where I want to talk about where we're going to hold meetings for the classroom. And you guys can see that pre-calc is Wednesday from 10 a.m. to 10:45. So what will happen is that I will be on my computer from 10 a.m. to 10:45. I will be at Google Meet. What Google has done for Classroom is that they had made right here for your class, they have a Google Meet link. It's right here posted. This was not here before. When you click on it, what will happen is it'll basically get started. Now, right now, my overhead camera has hijacked the camera, so you won't see it. But what you want to do is you won't see the image, is what I'm saying, because I have this going. So this right here, you're going to hit join now, and essentially it'll work just like Zoom. Now, Zoom, if you guys have seen like online and stuff, like it's an app that everybody can use, but they're having privacy issues, in particular with high school kids. So they're basically selling your data, and that like breaks laws and stuff for high school kids to use. So you would join, and so during that this time period, it will be an open, basically, question answer. Like, you guys can go over the homework. We can discuss, like, online, face to face, and we can go over any homework problems that you'd like, so that you can keep sharp. All right, and that you don't actually experience an intellectual slide. Okay, so we'll stop that. And so we're going to get down to business then. So what is going to be in Google Classroom are basically 2 handouts that look exactly the same. One is going to be called Notes and Examples, and the other one will look like basic homework. So I'm essentially going to be treating our notes and our homework very, very similar. And so, I'm going to work through them quick. You guys can pause it, rewind it, whatever you need to do to try to make sense of this. Now, this is actually a review from geometry. And so I'm going to throw in some new things that I know that Mrs. Moe didn't cover. Kind of like a first baby step into pre-calc here. But what do you remember from right triangles? Hopefully you remember that the major ones were 45, 45, 90s. Now you may want to get these notes and take them as we go just to kind of keep, if you just watch this, it's fine, but I think it's better for your memory if you do actually take notes along with it, and then you actually have these for your records, all right? But these right triangles, and then you had the 30, 60, 90. These are very, very important, very commonly used right triangles for all kinds of calculus and advanced topics, all right? And it's really good to kind of know these properties like that, okay? It's pretty much expected in calc because we use them all the time. Now, these guys are directly associated with sine, cosine, and tangent. And so sine, cosine, and tangent is basically, it's like a push and pull system. It's like when you pull on one leg, you shorten the other if it's a right triangle, all right? If you, shorten one leg, you lengthen the other. It's like a push and pull that sine and cosine. There's a reason why they call it cosine, because it's complementary to sine. When one goes one way, when cosine goes one way, sine goes the other, all right? And then tangent is basically the relationship between sine and cosine. So these are just ratios, all right? And you can kind of look at them as percentages even, all right? So if you remember that sine was actually, I'll put an S here, was the ratio of a right triangle of the opposite side over its hypotenuse. Cosine was the adjacent side over the hypotenuse, and then tangent was the opposite over the adjacent. Now these are just ratios by definition. Okay, that's all sine, cosine, and tangent are, is just a ratio. It's a fraction. And so if you remember then that if I'm looking from one part of the angle, okay, let's say I'm looking from this side right here, we would always label the longest side, the h, the hypotenuse, and that longest side is always directly opposite of this 90-degree angle. It's the longest side, okay? That has to be the longest side. And then the side opposite of this angle would be the opposite, all right? And then adjacent is the one that's left. But if you remember, adjacent just means something next to something else, okay? If a room is adjacent to another room, it means that it's touching it, it's next door. And so what it means to be adjacent is that it's adjacent to the actual angle. This opposite side is not touching this angle, it's opposite from it. But the adjacent is actually one of the legs of the angle. So we always call that angle attached to the angle of observation, we call that the adjacent. And so now we have a relationship between all three of these, and we can label them and designate them sine, cosine, or tangent. Now, if opposite, adjacent, and hypotenuse actually have values, then we can find out those trig ratios. And so that's all we're going to do today. We're just going to identify those trig ratios, and we're going to set them up. We want to be able to handle radicals. Okay, that's going to be very common when you're doing trig, is that there's going to be radicals here, like, radical 2 here. I see a radical 13. We want to be able to handle those appropriately and get rid of them if they end up in the denominator. So let's kind of make a mental note here that if you see a radical in the denominator, okay, we'll have some number up here. If you see a radical in the denominator, you have to change it. Okay? So something has to happen algebraically to get the radical out of the denominator. There's nothing wrong with it. It's just common practice for people to rationalize those denominators. That's what they call it, rationalize. Okay, so here we go. Now tangent. What I'm doing is I'm going to label with my pen actual theta here. Now you can see theta there. It's not this guy. There's no label there. So I have to look from theta because that's what it just said, tan of theta. Now I want to find the trig value. All right, I just want the ratio. I want the tangent of theta. So now that I have this angle designated, this is my opposite side. The sine across from the right angle is the hypotenuse, and then this one attached is actually is the adjacent. All right. Now tangent is defined as O over A, so opposite over adjacent. So the tangent of theta is simply the O over the A. Okay, now we would be done normally. But because we have the radical 2, we do have to change things. And so we've got to get rid of it. And so to get rid of it, we have to take one extra little mini step that I'm sure you guys will have no problem with. I have to multiply by 1. But notice that radical 2 over radical 2 is purposely used to get rid of the radical in the denominator because This now will become 6 radical 4. Okay, because radical 2 times radical 2 is radical 4. Now up here, I'm going to get 17 times radical 2, and that will just attach as it is. But I do know that the radical 4 is actually 2, so 6 times 2 is 12. Okay, now before you think that this radical 2 and this 12 can actually reduce, you can't, because radical 2 is an irrational number. It goes on forever. It's like 1.717, blah, 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 blah. It goes on forever. So this is it. This is fixed. That is the tangent value at theta. Now, why do we need to know that? No reason to know that right now. It's unnecessary for this particular assignment, okay? But tangent is extremely valuable for practical applications in calculus, okay? So let's see. Looks like I don't have any radicals in number 2, so I'm going to go ahead and look from theta. Okay, theta is here. I see this as the opposite. Okay, so that's the opposite. That's 7 over the hypotenuse. So this is the O. Sometimes I like to label these before I get started, just because I am less likely to make mistakes. So here's the O, here's the A, and here's the H. All right, and so tangent is designated as opposite over adjacent. So that is going to be 7 over 24. Final answer. It can't be reduced, so we just leave it. All right, and it looks like we got 3 tangents in a row. That's all right. I look from here. There's my O. That's the hypotenuse because it is directly from the right angle. And it's also the largest number. That's like another way that you can tell. If you have all 3 numbers, you can kind of tell, not kind of, you can tell which one is the hypotenuse because it has to be the longest side. All right, so that's the O. This is the A, so I'm looking for tangent again. Tangent of theta is O over A, which is 12 over 16. Now that actually can be reduced, and 4 will go into both at 3/4. So the tangent of theta is actually 3/4. All right, now I'm just going to keep going. I'm just going to talk my way through it. The sine is actually designated. I haven't hit any issues yet. Sine theta equals, what's that? That's actually, I'm drawing a blank. Oh my gosh, it's been so long since I did trig here. All right, so over H, so O, let's see, I'm looking from theta. O is across from theta, that's the O. And it looks like my H is actually 5, so that is 4 over 5. All right, and I'll just leave it like that. Could be a decimal. That's actually 4 over 5 is 0.8. So if you want to leave a decimal, I don't care. Doesn't matter. Okay, so now we just jumped into new territory. Number 5. You can see here that we have an SEC. And then you're going to notice here that all of these, well, sine and tangent I know. Okay, let's see. All right. But secant, this is called secant, this is cotangent, and this is called cosecant. Now I'm going to write those right here because these are new. Secant theta is actually pronounced secant. Let me spell it out for you. Secant. This one is called cosecant. Okay, and cotangent is literally that. Okay. Now on a pre-calc level, to just know these and kind of be aware of them, be able to find them is all that's really required, because in calculus they're gonna be very, very useful for us when we need to take derivatives and integrals. So these guys are very valuable, but we're gonna just use them just to kind of understand that they are fractions and they are out there. And so that's what I'm gonna do here. I have to know the definition in order for me to use them, though. What secant is, okay, so I'm going to start with this guy is basically, if you took cosine and flipped them, 1 over cosine. Now if you were to flip cosine, cosine is actually adjacent over hypotenuse, okay? So if I flip that, it's now h over a. That's it. That's all you got to know. Just know that secant is actually the reciprocal of cosine. All right, now that's what the other two are going to be with their respective original trig functions. So here for cosecant, you can probably guess that that's going to be the reciprocal of sine. So instead of being O over H, it's actually H over O. Okay? Now the graphs of these are very different than sine, cosine, and tangent. These guys are really strange to graph. All right, but we actually I keep writing tangent for cotangent. We're not going to be graphing them until the very end of this unit. So cotangent is actually 1 over tangent. So that is actually A over O. Okay? But here's one more thing that I do want to show you, is that tangent is also sine over cosine. Okay? It's also sine over cosine. So let me just kind of show you why that works. If sine is O over H and cosine is A over H, you can kind of see that the H's cancel out. Okay? So tangent can also be defined as sine over cosine. So by extension, if I want to do cotangent, okay, now these are all just definitions here. If I want to do cotangent, that would be like saying A over O. Okay, it's the same thing. Or we can say cosine over sine. Okay, it's all the same. So kind of like this you really want to pause, make sure you write it down, and maybe re-listen to this in case I might have gone too fast. No big deal. But I'm going to use this as basically my chart and actually to do these next 3 problems. Okay. All right. So if secant is, I'm looking from here. Okay. Now I'm going to go ahead and call this the O because it's opposite from the angle. I'm going to call that the H, and this is going to be the A. So if I go to secant here, it is the reciprocal of cosine, so that's a H over A. So H over A. So that's 3 and 13 over 9. Okay, so the secant of theta equals, that simplifies to 1 and 3, equals radical 13 over 3. Okay, because 3 goes into 9 3 times, and that's my final answer. All right, so no big deal. Secant, cosecant, and cotangent are just another ratios that much more useful down the road. Okay, now cotangent is defined here as A over O. So when I go over here, I'm looking for my A. Okay, now that's the O, and this guy is the adjacent. So it looks like the A over O is going to be 8 over 6. Okay, which reduces to 4 over 3. All right, that's it. Cosecant is defined over here as 1 over sine. So instead of going O over H, I'm going to go H over O. And H is here is 5, and the O is actually 3. So the cosecant of theta is 5 over 3. And I'm done. Now we go to sine. Let's see. So it switched to sine. No big deal. That's O. That's H. So it looks like sine of theta is O over H. Okay. All right. So now I'm going to do sine. Notice, take a second to kind of see what's going on now. How's the game changed? 1 through 8, no problem. As long as I know the definitions, I'm good. But number 9, we're missing something. We're missing a leg. And so you have to find out what that other leg is. This is a common ACT and SAT question where they're going to ask you for the trig ratio, and you're not going to know it because there's a leg missing. And so we're going to have to find that other leg. So if I look here, I'm going to have to use the Pythagorean theorem. So these 2 problems, you're going to have to use the Pythagorean theorem. And it's no big deal. And both of them are going to be a little different. So let's label these. This is my, now I'm going to switch this to A, B, and C. Because A squared plus B squared equals C squared, I'm switching my variables to something that's more common. You know, like that's my A, that's my B, and that's the C, because that's the hypotenuse. Okay? This A is not adjacent. It's just a label. All right? This B, okay, this C, they're not. They're just because that's how you learn the Pythagorean theorem. So, C squared equals A squared plus B squared. That should be tattooed somewhere in your brain. And so C, we don't know, so we go C squared equals A squared plus B squared. This one, hopefully you remember, if you have a 3 and a 4, this guy is, yes, he's 5. Because that's a 3, 4, 5 triangle. So If you took the square root of both sides, you get 5. So c equals 5. Now, when we get back to finding the sign ratio, that means that we want the O over H. So now that I have my 5 as my H now I'm going to switch him back to an H instead of being a C because I need it for my definitions. Okay. So the O coming from theta here is actually 4. So that's going to be 4 over 5, which again is 0.8, but that's no big deal. We got it. All right, now what if you actually have the C and you need an A or a B, whatever you want to call it. I'll just call him A. He's C because he is the hypotenuse, and this is B. So you have what's called the converse of the Pythagorean theorem to use. That is when you say B squared equals C squared minus A squared. Now all I did was just take A squared and put him to the other side and made him negative. Okay, now I can do that with B as well. If I need to find A squared, then I would just take C squared and minus B squared. Okay, these are called the converses of the Pythagorean theorem that you can use. Or just write this guy and just, fill it in and just solve for the numbers. It's the same thing. But B squared here actually equals 18 squared minus 14 squared. Okay, I actually do not know what 18 squared is. Nor do I know what that is off the top of my head. It's 128. Okay, I will take the square root of 128. That is 11.3, or I can just put the square root of 128. Okay, so tangent is, well, you know what, let's see if I can reduce this actually. Inside here is, well, 4 will go in there. 4 times 3, 32. He's a perfect square, so he's 2 and 2. This guy is going to be 16 times 2. So he's 4 and 4, 2 and 2, 2 and 2. So it looks like this guy has got lots of 2's here. 1, 2, 3, 4, 5, 6, 7. 7 2's. So I can take out 1, 2, 3 pairs of 2's. Okay, so that means that B equals 1, 2, 3. So 2 times 2 times 2 is 8. And I've got 1, 2 left over. So it's 8 radical 2. All right, so this is 8 radical 2. Now, if I want tangent, I have 14 over 8 radical 2. Okay. Now I can simplify these two real quick. 14, and divide those both by 2. So 7 over radical 2. Now I'm trying not to get into this area right here, so I'm running out of space here. But when I have 7 over radical 2 times 4, I have to get rid of the radical 2. I know I'm not talking on the microphone. All right, so I'm going to get 7 radical 2, and then 4 times radical 4 is 2. So I get 7 radical 2 over 8. Okay, now there'll probably be questions about this problem. It's running a little late for me, and the video is actually already at 22 minutes, so I'm going to actually stop this video, and then I'm going to start 11 and 12 on the next one. Okay.